Let's take a look at this probabilistic reasoning question, an easy one. Let's take a look together. So Leo runs a delivery route that includes biking to a dispatch center, loading packages onto a drone, and then relying on a scheduled 8 o'clock truck to deliver them. If the drone is delayed, the packages won't make it onto the 8 o'clock truck and will have to wait for a later one. Who cares? This sort of extra information is just there to consume your time, to distract you. Let's get into the probability bits. Over the past 50 days, the drone has failed to arrive at the dispatch center in time for the 8 o'clock truck on 10 days. So failed to arrive, the probability is 1 in 5 or 10 in 50. Similarly, on 10 of those 50 days, the 8 o'clock truck hasn't shown up on time as well. Equally, a 1 in 5 chance. Now, these events, they are independent of each other. Now, we've been told in the previous part that if the drone is delayed, the packages won't make it onto the 8 o'clock truck. But if the truck's delayed, then it doesn't matter if the drone has arrived. They are independent of each other, which means we don't need to kind of multiply these probabilities together. So is it more likely than not, look at the wording of the question carefully, that Leo's packages will be delivered on time tomorrow? Option A, yes, the drone and the truck have each been on time 40 out of 50 days, so the delivery should be on time tomorrow. Yes, this is true. This is true. It is more likely that Leo's package will be delivered on time tomorrow. Each event is independent from any other event, so we can use the past record of 1 in 5 chance or a 4 in 5 chance that the drone is on time, a 4 in 5 chance that the truck is on time. So the probability that the delivery is going to be on time tomorrow, we can base it off that. So A is our correct answer. So let's move on to the next question straight away. Let's not waste time in our exam. Let's have a look at the other ones just to explain why they're wrong. So B, yes, if the drone is delayed, the truck may be too, so it might still work out. Well, they are independent events. Just because the drone is delayed doesn't mean that the truck will be delayed. C, no, on 20 of the 50 days, either the drone or the truck was delayed, so it's unlikely the delivery will be on time. 20 out of 50 is not a majority, it is still the minority, so that would mean that it is still more likely than not. And then D, no, each day is unpredictable, so there's no way to reliably guess what will happen tomorrow. Each day is unpredictable, but we know that there is a 1 in 5 likelihood that the drone will be late or that the truck will be late as well. So D is incorrect. Let's take a look at this medium level probabilistic reasoning question. At a school book fair, there are 15 mystery books and 15 adventure books on a table, all wrapped so students choose without knowing the genre. Again, who cares? We know we've got 15 out of a total of 30. By midday, 5 mystery books and 4 adventure books have been taken by students. If a student now picks a wrapped book at random, has the chance of picking a mystery book increased? The reason this is a medium level difficulty is because you need to kind of remember that the books have been removed from the total. So originally we have 15 out of 30. That's the probability. So that's the same as a half. And then later on at midday, 9 books have been removed in total. So it's going to be out of 21. And 5 of the mystery books have been removed. So there are going to be 10 mystery books. So it is now 10 out of 21. Let's take a look at our options. Is the chance of picking a mystery book increased? No, it has decreased. 10 out of 21 is less than a half, so D is our correct answer. Let's take a look at this hard probabilistic reasoning question. The reason this one is hard is because you need to do some conversions. A gaming company releases a new video game and conducts 2 feedback surveys, A and B, with different gaming communities to assess player reactions. Who cares? We can skip, we don't want to skip it, but we don't want to spend too long trying to understand what the gaming company is trying to achieve. Let's get into the data. In survey A, 200 gamers were asked for their opinion. 84 said they enjoyed the game, 76 said they didn't enjoy the game, and the rest didn't respond. In survey B, 45% of the gamers said they enjoyed the game and 25% of the gamers didn't respond. The company wants to use the survey that presents the game in the most positive way. Should they choose survey A? So the problem here is we're comparing raw numbers to a percentage. So let's convert those raw numbers into a percentage. The other challenge on top of this is the idea that in survey A, some of the gamers didn't respond. They asked 200, but only 84 plus 76 actually responded. Only a total of 160 gamers actually responded. So let's work out the percentages using our calculator super quickly. We get 84 out of 160, so 52.5%. And then we don't have any other number to compare those that didn't enjoy the game, so let's not bother calculating that. So we're comparing 52.5% to the 45% from survey B. So we can see that survey A makes the game seem better. More people say they enjoyed the game. So should they use survey A? Yes, they should. Is it going to be A or B? A says because the response rate in survey A was higher than that in survey B. B, because a higher percentage of gamers in survey A than in survey B said they enjoyed the game. B makes the game seem better because there are more people saying that there is, or a higher percentage of people are saying that they enjoyed the game.